Hi, this is Miss Pafflin, and I'm going to go through the practice test for Unit 5, Quadratic Functions. For each item, select the best answer, show your work, or explain your reasoning with words. Use the provided graphs to answers 1 through 8. So we have diagram 1, 2, and 3, and number 1 says, identify the axis of symmetry of each quadratic function shown in the diagrams above. So for the axis of symmetry, that's going to be the x value of our vertex. And we can identify using the graphs. So right here is my vertex, which is at 0, -2. So the x value is 0. So diagram 1. X equals 0. Remember to write it as an equation with x equals. Then we have our diagram 2. Vertex is at -3, 0. So for diagram 2, x equals -3. And diagram 3, vertex is at 2, 2, so x equals 2. Number 2, identify the vertex of each quadratic function shown in the diagrams above. Well, I already went through and labeled those. So 1, 0, -2. 2, -3, 0. Oh, that was number 2, not number 3. And number 3, 2, 2. So that vertex is going to be that minimum or maximum point. And that's where that line of symmetry goes. 3, identify the zeros, roots of each quadratic function shown in the diagrams above. So remember, for your roots or zeros, those are the x-intercepts, which are also called the solutions to the quadratic function. So for diagram 1 touches the x-axis at 1, 0 and -1, 0. Two solutions. Diagram 2, the vertex is the solution, or the zeros and roots, so that would be -3, 0. And for diagram 3, the vertex is above the x-axis, so this one has no solutions. 4, identify the minimum and maximum, if any, of each quadratic function shown in the diagrams above. So when we're identifying minimum or maximum, you are only looking at the y value. And so we already have our vertex labeled, so we're just going to look at the y value for those. So for diagram 1, our vertex was 0, -2. Our y value is -2, and that's a minimum. So when it's opening up, it has a minimum -2. Diagram 2 is opening down, so this has a maximum, and the y value is at 0. And 3. This one also has a minimum, and the y value is at 2. Five, identify the domain and range for each quadratic function shown in the diagrams above. So unless they give a real world situation, the domain will always be all real values of x, because this parabola keeps going forever and ever and gets wider and wider, so eventually it's going to touch all the values of x. And then we have to look back to our minimum of -2 for diagram 1. So this means that it's opening up, it's going greater than or equal to -2 for our range. So you will use these values to help with the ranges of all three. So range all real values of y such that y is greater than or equal to -2. Diagram 2, again, the domain is going to be all real values of x. And then the range has a maximum of 0. So now we know that it's going to be less than or equal to 0. All real values of y such that y is less than or equal to 0. And then diagram number 3, again, domain all real values of x, and then for range, all real values of y such that y is, and that one has a minimum of 2, so we know it's going greater than or equal to 2. Number 6, compare each quadratic function from the diagrams above with the parent function f of x equals x squared. So if I go back and actually graph f of x squared, it always has a point at 0, 0. It's going to open up. If I plug in some values for x squared, 1 squared is 1, so I know there's going to be a point at 1, 1, and -1, 1. 2 squared is 4, so I know there's going to be a point at 2, 4, and -2, 4. So I'm just going to draw this on here to help me visualize it. So from my vertex, I'm going up 1 over 1, and this one, we're going up 2 over 1. Then I'm going from that, at my 1, 1 point, I'm going 1, 2, 3, up 1 over 1, and then from this point, going 1, 2, 3, 4, 5. So it seems as though it's a little narrower than the parent function. Diagram 1 is a little narrower. So I know that my a value is greater than 1 if it's narrower. It also has the same axis of symmetry of 0, but it's translated down 2 units. So those are some things I'm going to say for diagram 1. So I'm going to create a table. Diagram 1, 2, and 3. All right, so diagram 1, same axis of symmetry at x equals 0. 1 is narrower than the parent function f of x, so a must be greater than 1, and it's translated down 2 units. Diagram 2 in comparison to the parent function. So this one has a parabola that is going down, so it's facing downward, so A would be negative. This one is translated 3 units to the left and has an axis of symmetry of -3. And then we could also say it's reflected over the x-axis since it is pointing down, and the A value would be negative. So 2 has different axis of symmetry at x equals -3. 2 is narrower. A is greater than 1. Reflection over x-axis. Translated 3 units left. A value is negative. And for diagram 3, this one seems to be the same width because for my vertex, if I go up 1, right 1, up 3, right 1, it seems to be the same width. So the A values both equal 1 for this diagram and the parent function. This one is translated right 2 units, up 2 units, and it has an axis of symmetry of 2. So 3 has different AOS, x equals 2, same width, A equals 1, translated right 2 units and up 2 units, both parabolas open up, A is positive. 7, identify the vertex of the given quadratic h of x equals 3x squared plus 4x minus 8. So to find the vertex, we first have to find the axis of symmetry. So the formula for the axis of symmetry, x equals negative b over 2a. B value is 4, so negative 4 over 2 times 3. Negative 4 over 6 equals negative 2/3 simplified. And then we can keep it in fraction form, or you can convert to decimal. I'm going to keep it in fraction form for now because sometimes when we convert to decimal we have to round and then we don't get as accurate of an answer, so keeping it in the fraction form will be more accurate. Now I need to plug this into the formula for x to find my y value, h of negative 2/3 equals 3 times negative 2/3 squared plus 4 times negative 2/3 minus 8. First we want to do exponents. So when you have a fraction that you're squaring, do the numerator. So negative 2 squared is 4. 3 squared is 9, so 4/9. Then 4 over 1, multiply across. 4 times negative 2 is negative 8. 1 times 3 is 3, 8 negative 8/3. And then minus 8, and I'm just going to make that in a fraction. All right, then we need to multiply 3 times 4 is 12. 1 times 9, 12/9. Then I'm going to convert these so they have the same denominator of a 9 so that I can subtract them more easily. So 3 times 3 is 9, so negative 8 times 3 is 24, negative 24. And then minus 1 times 9 is 9, so 8 times 9 is 72 over 9. Then I just subtract my numerators. 12 minus 24 is negative 12. Minus 72 is negative 84. So h of negative 2/3 equals negative 84 ninths. So we could keep these in fraction form, or I can round these to a decimal. So negative 84 ninths is about negative 9.3, repeating decimal. Negative 2/3 is about negative 0.667. So I'm going to write these both in fraction and decimal. So negative 2/3 is my x value. Negative 84 ninths is my y value, or we can write it as a decimal, negative 0.667 and negative 9.3 repeating. So these would be, or this is the vertex either in decimal or fraction form. Number 8, identify the solutions of the given quadratic, 4x squared plus 17x plus 15. So for this, we can use any of those 5 methods. You have graphing, factoring, the square root method, completing the square, and the quadratic formula. You kind of just want to look at it and see what would be the best option. So a equals 4, I can't divide everything by 4 where I would get whole numbers, so completing the square is not an option. Factoring, again, it's harder when your a value is greater than 1. So I'm going to avoid factoring. I'm going to use the quadratic formula. So a equals 4, b equals 17, and c equals 15. So x equals negative b, so negative 17, plus or minus square root of b squared, 17 squared, minus 4ac, so minus 4 times 4 times 15, over 2a, 2 times 4. Then I want to do under the radical first. 17 squared is 289. Negative 4 times 4 is negative 16. Negative 16 times 15 is negative 240. 2 times 4 is 8. 289 minus 240 is 49, so x equals negative 17 plus or minus square root of 49 over 8. Square root of 49 is 7. X equals negative 17 plus or minus 7 over 8. Then we want to create our 2 equations. X equals negative 17 plus 7 over 8. Negative 17 plus 7 is negative 10. So negative 10 over 8, which is also negative 1.25. And then my other equation would be x equals negative 17 minus 7 over 8. Negative 17 minus 7 is negative 24 over 8. Negative 24 divided by 8 is negative 3. So x equals negative 1.25 and x equals negative 3. Number 9, identify the solutions of the given quadratic. 2x squared plus 4x minus 70. So for this one, I can divide everything by 2. Always look for that greatest common factor. So then that gives me x squared plus 2x minus 35. Now, looking at this, I can factor this. Negative 35 would be my factors to multiply to equal that, and then they have to add to 2. So I know x minus 5, x plus 7, negative 5 times 7 is negative 35, negative 5 plus 7 is positive 2. And put it equal to 0, and then we put each of these binomials equal to 0 and solve. We have to do the inverse. If it's x minus 5, I have to add 5 to both sides. X equals 5. Then x plus 7, subtract 7 from both sides. X equals negative 7. two solutions, x equals 5 and x equals -7. All right, number 10, solve the following quadratic function by completing the square. M of x equals 2x squared plus 34x plus 120. So looking at this one, we have to complete the square. So we want a to equal 1 when you're completing the square. So I need to divide everything by 2. X squared plus 17x plus 60. And then we put it equal to 0. When you're completing the square, you need to have your form be ax squared plus bx equals c. So if my c value is plus 60, I have to move it to the other side of the equal sign by subtracting 60. X squared plus 17x. I'm going to complete the square, so I'm going to add these boxes or these squares for when I put my completing the square. To complete the square, it's b divided by 2a. So my b value is 17 over 2 squared. 17 divided by 2 is 8.5. 8.5 squared equals 72.25. So this is what I'm going to plug in. 72.25. X squared plus 17x plus 72.25 equals, and then negative 60 plus 72.25 is 12.25. Then I have to put this in factored form. Your factored form goes back to b divided by 2, 8.5. So x plus 8.5 squared equals 12.25. Then we need to do the square root. We get x plus 8.5 equals plus or minus 3.5. Now this is where I see the most mistakes. I see people then doing x plus 8, adding 8.5 to 3.5 and then subtracting it. That's not what you do. You're adding 3.5 and subtracting 3.5. This 8.5 stays the same sign. We just have to move it to the other side of the equal sign. So if it's x plus 8.5, I subtract 8.5 from both sides. So x equals negative 8.5 plus or minus 3.5. Negative 8.5 plus 3.5 is negative 5. And negative 8.5 minus 3.5 is negative 12. Those are the two solutions. Number 11, solve the following quadratic by factoring. Again, for factoring, we want to get a equal to 1 to make it easier. You could do it, but we can divide everything by 2. So that would give us x squared minus 5x plus 6 equals 0. Now I need to find two numbers that multiply to 6 and add to negative 5. So I know they need to both be negative because a negative times a negative equals a positive, and then added together would equal to negative. So I know I could do negative 3 and negative 2. Negative 3 times negative 2 equals positive 6. Negative 3 plus negative 2 equals negative 5. Set them each equal to 0. Solve by doing the inverse. If it's minus 3, I need to add 3 to both sides. X equals 3. Add 2 to both sides. X equals 2. These are the two solutions. 12. Use the discriminant to determine how many solutions the quadratic function has. Discriminant is b squared minus 4ac. So a equals 20, b equals negative 13, and c equals 2. Plug those in. Negative 13 squared minus 4 times 20 times 2. Negative 13 squared is 169. Negative 4 times 20, negative 80, and negative 80 times 2 is negative 160. 169 minus 160 equals 9. This value is greater than 0, so this has two real solutions. If it were equal to 0, it would have one real solution, and if it was less than 0, negative number, it would have no real solutions. 13, the function h of t equals negative 4t squared plus 16 represents the height in meters of a bungee jumper above the river t seconds after they jump from a raised platform. Find the bungee jumper's maximum height. Again, we need to find the AOS, axis of symmetry. To find the vertex, maximum height is your vertex. So x equals negative b over 2a. For this one, a equals negative 4. B, we don't have just a t value, a t variable by itself, so b equals 0. And c equals 16. So it would be 0 over 2 times negative 4. 0 divided by negative 8 equals 0. So x equals 0. Plug that into the function. Negative 4 times 0 squared plus 16. 0 squared is 0 times negative 4 is 0. H of 0 equals 16. So that means the bungee jumper was 16 meters for the maximum height. And that would be your y-intercept. So think about a bungee jumper, it's starting at that height and then jumping off the ledge. They're only going to go down from there when they bungee jump. So their highest point would be their y-intercept, their starting point. 14, refer to item 13. Determine how long it took the jumper to reach the water. So for this one, we need to find your x-intercepts, because that would be when the height is 0 feet, and that's your x-intercept, your solutions. So the equation was negative 4t squared plus 16 equals 0. So to find my solutions, I can use the square root method. I don't have the b value. You can use that when you don't have your b value. So I'm going to subtract 16 from both sides. Negative 4t squared equals negative 16. Divide by negative 4. T squared equals negative 16 divided by negative 4 is 4. Square root both sides. T equals plus or minus 2. Now, that means the solutions are at positive 2 and negative 2. But a negative 2 does not make sense in this situation because you can't have negative seconds. So we would only use the positive 2 seconds it took him to reach the water. Refer to item 13. What is a reasonable domain and range for the situation? So for this one, he started at 0 seconds when he was up on the ledge about to jump, and then it took 2 seconds. So our domain would be, and it would be all real values because we can have decimals and fractions, all real values of x such that x, so it's going to be between 0 and 2. So we put 0 less than or equal to x less than or equal to 2. And then for the range, all real values of, oh, and I guess in this situation we're using t, so instead of x I would say t. Try to use the same variable, t. And then it was, what did they give us? H of t. So all real values of h of t, and that would be between 0 feet and the highest point was 16 feet. 0 less than or equal to h of t, which is less than or equal to 16. 16, solve the system of equation. So for this one, we need to, they both have y equals. So we can just set them equal to each other because I can substitute x squared minus 4 for this y. So I'm actually going to stop the video here because I have a class coming in soon and I need to prepare for that. So I will post another video going over the rest of the packet. See you then.